Before anything had a shape, a sound, or a story, the universe existed in a state beyond imagination, an infinite stillness compressed into a single, blazing point. No atoms, no stars, no galaxies, no time flowing forward or backward, only a dense, silent possibility waiting for its first breath. This is where our tale begins, not with Earth, not with humanity, but with the mysterious moment before creation itself. Then, in an event so powerful that even language fails to describe it, the universe awakened. The Big Bang was not an explosion in space, it was the creation of space. A surge of energy flooded the void, carving out the dimensions in which all stories would one day unfold. In less than a second, the cosmos expanded faster than light, stretching, cooling, and giving birth to the first subatomic particles, quarks, electrons, neutrinos, chaotic fragments of what would one day become everything we know. But the universe was still too young, too wild, too hot for complexity. For hundreds of thousands of years, it was a swirling ocean of light and plasma, thick and opaque as fog. Yet hidden within this storm, patterns were forming. Gravity whispered faintly, urging matter to gather. Photons collided with electrons in an endless cosmic dance. Slowly, the chaos softened. Slowly, darkness made room for structure. Then came the first great transition, the moment when atoms formed. Electrons spiraled around protons, locking into place like seeds settling into soil. Hydrogen and helium emerged, drifting through the darkness like newborn stars without a flame. With this, the universe entered its first night. The light of the Big Bang faded, leaving behind a silent, infinite darkness. For millions of years, nothing existed but these simple atoms, drifting through a cosmic ocean with no destination. There were no planets, no moons, no life. Only the quiet hum of possibility. This long darkness is known to scientists as the Cosmic Dark Ages, a period when the universe waited for the next chapter to unfold. And then, something extraordinary happened. Under the influence of gravity, clouds of hydrogen began to gather, compressing slowly over millions of years until, at last, the pressure ignited nuclear fire. The first stars were born. They burned hotter than anything that exists today, blue and massive, living short and brilliant lives. These ancient stars, called Population 3 stars, were the universe's first storytellers, illuminating the darkness for the very first time. But they were more than lights in the sky. They were factories, creators, alchemists. Inside their cores, hydrogen fused into helium, helium into carbon, carbon into oxygen, forging the elements that would one day become oceans, mountains, forests, and living beings. These early stars sowed the seeds of chemistry, scattering heavy elements across the cosmos when they died in violent supernovae. Every explosion sent matter hurtling across space, matter that would drift for billions of years before finding new purpose. Yet humanity, for most of its history, did not know this truth. To ancient civilizations, stars were gods, guardians, and symbols carved into myth. No one imagined that those distant lights were the very reason we exist. Even great thinkers like Aristotle and Ptolemy envisioned the heavens as perfect and unchanging, unaware that the stars themselves lived and died. The mystery began to crack only in the last few centuries. In 1814, a young German optician named Joseph von Fraunhofer observed strange dark lines in the sun's spectrum, clues that starlight contained hidden messages. Later, in the mid-1800s, Gustav Kirchhoff and Robert Bunsen realized these lines revealed a star's chemical makeup. Suddenly, the stars were no longer unreachable mysteries. They were readable, and what humanity read changed everything. By analyzing starlight, scientists discovered that stars contained the same elements found on Earth: hydrogen, helium, oxygen, carbon. It meant something profound. Earth was not unique. The building blocks of life existed everywhere. But the full revelation came in 1957, when four scientists, Margaret Burbidge, Geoffrey Burbidge, William Fowler, and Fred Hoyle, published a groundbreaking paper explaining how stars create elements. Their work showed that every atom heavier than hydrogen was born inside a star. Every carbon atom in your DNA, every oxygen atom in your blood, every calcium atom in your bones, all of it created by stars. But Chapter 1 does not end with scientific discovery. It ends with an emotional truth far deeper than data. We are not visitors in the universe. We are not outsiders looking at the sky. We are the universe, awakened and aware. The hydrogen in your body is 13.8 billion years old, older than Earth, older than the sun, older than every mountain, river, and living creature. The iron in your blood was forged in the collapse of a massive star. The calcium in your bones was born in a supernova. The gold in your jewelry was created in the collision of neutron stars. Every atom inside you carries the memory of cosmic events so ancient and violent that the human mind struggles to comprehend their scale. And so, the unknown is no longer a void. It is the place where our story began. A place where matter, energy, and time performed a symphony that would one day give rise to galaxies, planets, life, and consciousness. In the end, the greatest mystery was not how the universe began, but how the universe became capable of wondering about itself. That we are the question and the answer. We are the mystery and the meaning. We are the unknown, discovering itself. The universe had already performed its grand experiments long before Earth formed. But humans, with curiosity burning brighter than any star, sought to recreate those cosmic processes, not in stellar cores, but through thought, observation, and the delicate instruments of science. Our journey begins not with telescopes, but with the earliest experiments of elemental understanding. In the 17th century, Robert Boyle, the father of modern chemistry, began questioning the ancient Greek idea of earth, air, fire, and water. His experiments hinted that matter was built from something deeper, something invisible, structured, and universal. Though he did not know it, Boyle was taking the first human steps back toward the stars. 2 centuries later, the experiments grew bolder. In the early 1800s, John Dalton introduced the modern atomic theory. His meticulous measurements showed that elements combined in fixed proportions, suggesting that atoms, tiny, indivisible spheres, were the building blocks of everything. Dalton had no idea where atoms came from, but he gave us the vocabulary needed to ask that question. Meanwhile, astronomers began experimenting with a new tool, light. Starlight had always reached Earth, but no one knew how to read it. That changed in the 1800s with Joseph von Fraunhofer, a German physicist and lensmaker. While studying sunlight through a prism, he observed mysterious dark lines. These lines, now called Fraunhofer lines, were not random. They were signatures, chemical fingerprints imprinted into light. This discovery transformed astronomy forever. For the first time, scientists realized that starlight carried secrets of stellar chemistry. But unlocking that information required another experimenter, Gustav Kirchhoff, who discovered that these spectral lines matched the colors absorbed and emitted by elements heated in a lab. Suddenly, the universe opened like a book. And for the first time, humans knew stars were made of the same matter found on Earth. Still, this raised a deeper question. If stars contain the same elements as Earth, were the elements themselves born in the stars? To answer this, scientists needed to experiment not with light, but with the fundamental forces of nature. In the early 20th century, the newly emerging field of nuclear physics took center stage. Ernest Rutherford's gold foil experiment revealed that atoms were not solid spheres, but mostly empty space with a dense nucleus at the center. This discovery laid the foundation for nuclear reactions, the same reactions powering the sun. At that time, the universe's construction plan was still invisible. Scientists knew stars burned. They knew atoms existed. But how did stars build atoms? What furnace could forge the ingredients of life? One of the most important clues came from a simple experiment in 1920 by British astrophysicist Arthur Eddington. He reasoned that the sun's energy came from fusing hydrogen into helium, transforming lighter atoms into heavier ones. His idea was radical, almost unbelievable, but it created a bridge between stellar fire and cosmic creation. To test Eddington's theory, physicists needed to experiment with nuclear fusion itself. In the 1930s, scientists like Hans Bethe refined these ideas, calculating the processes by which stars fuse hydrogen, helium, carbon, and beyond. Bethe's equations were experiments of the mind, mathematical windows into stellar hearts. Meanwhile, humanity built its own tools to probe the atomic universe. Particle accelerators, like the one constructed in the 1930s by Ernest Lawrence, smashed atoms together at enormous speeds, recreating small echoes of the reactions inside stars. These experiments revealed cosmic truths hidden since the dawn of time. Still, one great mystery remained. Where did elements heavier than iron come from? Iron is the stopping point. In stellar cores, fusion up to iron releases energy, but forging heavier elements consumes energy, not produces it. So where did gold, uranium, iodine, and other heavy atoms originate? The answer required one of the greatest scientific experiments of the century, one not performed in a laboratory, but through theory, observation, and the careful assembling of clues. Between 1953 and 1957, for scientists, Margaret Burbidge, Geoffrey Burbidge, William Fowler, and Fred Hoyle, worked together on a monumental project. Through years of calculations, data comparison, and nuclear physics experiments, they created the B superscript 2 FH theory, explaining how every element in the periodic table was built. Their work revealed something stunning. Heavy elements formed in violent moments, supernova explosions, when dying stars collapsed and rebounded in colossal blasts, sending freshly made atoms scattering into space. The universe was not just peaceful creation. It was creation through destruction. This theory was supported by new experiments and observations. Astronomers studied supernova remnants, like the Crab Nebula. Physicists examined radioactive decay rates in meteorites. Spectroscopy revealed heavy element signatures in the ashes of dead stars. Every clue, every experiment aligned. By the 1960s, humans began conducting experiments with cosmic radiation itself. When Arno Penzias and Robert Wilson accidentally discovered the cosmic microwave background, they found the cooling echo of the Big Bang, proof that the universe had once been hot enough to create the first building blocks of matter. Later experiments with satellites like COBE, WMAP, and Planck mapped this radiation in astonishing detail, revealing cosmic fluctuations, tiny irregularities, that would become galaxies, stars, planets, and eventually life. Humanity had traced its origin not through one experiment, but through thousands, scientific, observational, mathematical, theoretical. Each experiment peeled back a layer of the cosmic story. And through all of this effort, one truth emerged. The universe did not build us all at once. It built us through time, through fire, through chaos and order, through fusion and explosion, through star birth and star death. We are the conclusion of countless cosmic experiments. Atoms forged in ancient suns, molecules shaped in interstellar clouds, planets sculpted from stardust, life sparked through chemistry, consciousness awakened through evolution. And now, those very beings, made from stars, perform their own experiments to understand how they came to be. The universe reveals its truths slowly, like a curtain of stardust lifting one shimmering thread at a time. And Chapter 3 begins at the moment when those threads finally aligned, when human curiosity met cosmic history, and when scientists realized a truth so breathtaking that it changed how we see ourselves forever. We were not merely born in the universe, we were born from it. For centuries, philosophers pondered the nature of matter. The Greeks imagined four elements: earth, water, air, and fire, believing everything emerged from their balance. Mystics in the Middle Ages turned metals into symbols of body and soul, convinced that gold was divine and that silver carried the purity of the moon. But it wasn't until the 20th century that humanity took the first real step toward understanding the true origins of the elements. Our story begins in 1920, when Sir Arthur Eddington, an English astronomer, proposed a mind-bending idea that stars were not dead lights in the sky, but nuclear furnaces, fusion engines capable of forging new matter. He claimed that the sun's energy came from hydrogen transforming into helium, an idea completely revolutionary at the time. Scientists debated him. Many thought he was dreaming. But Eddington insisted, the elements are born in the hearts of stars. It sounded poetic, mystical, unreal. Yet it planted a seed, one that would bloom decades later. The real breakthrough arrived in 1957, in a small meeting room at the California Institute of Technology. For scientists, Margaret Burbidge, Geoffrey Burbidge, William Fowler, and Fred Hoyle, We're about to publish a paper so transformative that physicists still call it the Magna Carta of stellar nucleosynthesis. Hoyle had already proposed a bold idea. Heavy elements cannot form in the early universe. They must be cooked inside massive stars. But it was Margaret Burbage's precise observations of stellar spectra and Fowler's expertise in nuclear reactions that tied every piece together. Their legendary paper, known simply as B superscript 2 FH, mapped the cosmic recipe book of creation. Hydrogen and helium formed in the Big Bang. Carbon, oxygen, nitrogen forged inside old stars through fusion. Iron created in the dying core of massive stars. The gold, uranium, platinum, born only in the universe's most violent events, supernova explosions and neutron star collisions. This was the revelation. Every atom heavier than helium was created somewhere inside a star. Every carbon atom in your DNA. Every oxygen molecule in your lungs. Every iron atom in your blood. Every calcium crystal in your bones. All of it, every piece, was once part of a star that lived, burned, collapsed, and died long before Earth was even dust. But the story grows even more powerful. In 2017, the Laser Interferometer Gravitational Wave Observatory, better known as LIGO, detected ripples in spacetime itself. These ripples were the echo of two neutron stars spiraling together and colliding in a catastrophic explosion called a kilonova. At telescopes around the world, scientists watched a flash of blue and gold erupt into the cosmos. And the data revealed something extraordinary. This single cosmic event created enough gold to fill Earth's oceans. The universe wasn't just forming elements inside stars. It was forging them inside the universe's rarest and most violent collisions. Suddenly, a deeper truth emerged. The gold in rings, crowns, electronics, and human treasures originates not from Earth, but from ancient explosions beyond imagination. But let's step back, deeper into the revelation. Imagine the first second after the Big Bang. The universe was a storm of quarks, electrons, neutrinos, a boiling sea of raw energy. As it expanded, it cooled, and the first atoms formed, hydrogen and helium. Nothing heavier. No carbon. No oxygen. No iron. No life. The universe was young, empty, and waiting. Then stars were born. Massive clouds of hydrogen collapsed under gravity, igniting nuclear fusion. These first stars, known as population 3 stars, were enormous, unstable, incandescent giants. They lived fast, they burned bright, and they died explosively. Their deaths seeded the cosmos with the first heavy elements. Those elements drifted through space, forming new stars, new planets, new possibilities. They created the raw materials for chemistry, biology, and eventually, consciousness. By the time Earth formed 4.5 billion years ago, the galaxy had already lived through generations of stars. Our solar nebula was not pure hydrogen. It was enriched with the ashes of the dead. This was the revelation that reshaped everything. We are the second, third, fourth generation children of the universe. We stand on the remains of what came long before us. Astronomers like Carl Sagan later captured this truth in words that became immortal. We are made of star stuff. But behind that poetic line is a precise scientific reality. When you inhale, your breath contains oxygen atoms created in ancient red giants. When your heart beats, the iron in your blood carries the signature of a long-dead supernova. When you think, the phosphorus in your neurons, an element essential for DNA, was forged in stars that burned out billions of years ago. The revelation is not symbolic. It is literal. We are not just observing the universe. We are the universe, observing itself. And now imagine this. Every person you have ever met, every creature, every flower, every mountain, every drop of water, every story humanity has ever written, is made from the dust of stars that existed before Earth was even conceived. The universe built us from its own remains. We are recycled light, ancient matter wearing new shapes, stardust learning to understand itself. Humanity often looks for origin stories in myths, in scriptures, in legends told around old fires. But science reveals something just as beautiful, just as sacred, and infinitely older. The first chapter of your story began in a star billions of years before your birth. The revelation is simple yet overwhelming. You are not small. You are not insignificant. You are part of a cosmic lineage older than memory itself. And as we step out of Chapter 3, the curtain lifts again. Because now we must ask, what did this revelation mean for us? For science? For life? For the universe's plan? The revelation that we are made of star stuff did more than satisfy curiosity. It rippled outward, reshaping science, society, and human imagination. The consequences of understanding our cosmic origin are profound, interweaving the physical, technological, philosophical, and emotional layers of existence. What was once poetic metaphor became measurable reality, linking the heavens with the earth, and the earth with life itself. In the realm of science, the consequences transformed entire disciplines. Astrophysics, nuclear physics, and cosmochemistry converged to explore the universe as a grand laboratory. Knowing that elements essential to life, carbon, nitrogen, oxygen, phosphorus, originated in stars, scientists could trace planetary formation, the chemistry of exoplanets, and the potential for life elsewhere. Observatories like the Hubble Space Telescope and instruments like the ALMA array scanned distant galaxies, searching for star-forming regions rich in these life-bearing elements. The study of cosmic chemical evolution became a map of possibility, linking the cosmos to human existence in ways never imagined. But the impact extends beyond observation. Particle physics, inspired by the behavior of atoms in stellar furnaces, advanced technologies on Earth. Nuclear reactions in laboratories now mimic, on a miniature scale, the processes that powered the first stars. Fusion research, aimed at clean energy, draws directly from knowledge of cosmic nucleosynthesis. Even materials science benefits. Understanding the formation of heavy elements informs the creation of superalloys, semiconductors, and catalysts. Humanity leverages the lessons of stars to improve life, industry, and the very future of energy on our planet. The consequences of revelation are also temporal. By mapping the journey of atoms from stars to Earth, scientists uncovered the history of our planet in unprecedented detail. Meteorites, cosmic dust, and isotopic ratios act as messengers from billions of years ago. Each sample studied in a laboratory connects the microcosm of an element to the macrocosm of the galaxy. From ancient carbon in meteorites to iron isotopes formed in supernovae, these studies allow humanity to read the diary of the universe, page by page, atom by atom. Society, too, feels the echo of this knowledge. Philosophically, realizing that we are composed of starborn elements fosters humility, awe, and interconnectedness. Cultural narratives, art, and literature increasingly embrace cosmic origins as a metaphor for unity. We see ourselves not as separate from the universe, but as participants in its ongoing story. Education in astronomy, chemistry, and physics now carries not only technical knowledge, but also existential insight, that our lives, fleeting though they are threaded into a continuum billions of years long. On a practical level, understanding the distribution of elements in the cosmos informs resource management and planetary exploration. Elements once thought rare or obscure become targets for mining, both on Earth and potentially on asteroids. Technetium, gold, platinum, and other heavy elements formed in supernovae are not merely theoretical curiosities. They become tangible goals for human technology. Space agencies and private companies alike plan for a future where humanity's survival and progress may rely on the intelligent use of materials forged in ancient stellar furnaces. Medicine also reflects these consequences. Technetium, 99M, a radioactive isotope derived from nuclear experiments inspired by stellar fusion, enables millions of diagnostic scans annually. The gold and platinum in medical implants and treatments trace their origins to cosmic processes that predate life itself. Understanding these connections emphasizes the unity of natural history, physics, and human health. The revelation that the cosmos built us is not abstract. It is embedded in the atoms that sustain and heal us. Emotionally, the consequences are no less profound. To recognize that our bodies and the world around us are composed of matter older than the Earth evokes a unique kind of awe. Daily life transforms. Breathing, touching, eating, and thinking become rituals of connection with billions of years of cosmic history. This knowledge bridges the scientific and the spiritual, offering meaning that transcends culture, geography, and era. Humanity, once isolated in its own perception of time and space, now sees itself woven into the universe's grand tapestry. The environmental dimension is also significant. Realizing that Earth is a rare and precious cradle for starborn elements emphasizes stewardship. The same cosmic processes that made life possible demand careful handling of resources. Mining, energy production, and technological development now carry ethical responsibility. Consequences are not merely academic, they are moral. By understanding our elemental heritage, we are compelled to protect the planet and use its materials wisely, preserving the delicate balance forged over billions of years. Culturally, the revelation sparked a renaissance of cosmic imagination. Films, books, and music embrace themes of stardust and human origin. Science outreach programs teach children that they are literally connected to the stars. Art installations celebrate the journey of elements from stellar cores to human hands. This narrative, both scientific and symbolic, reshapes how societies understand identity, belonging, and purpose. Yet perhaps the most profound consequence is existential. Humans now know that life, consciousness, and civilization are not accidents, but emergent properties of cosmic processes spanning billions of years. Stars exploded, atoms drifted, planets formed, chemistry evolved, and consciousness emerged, a continuous chain linking the inanimate and the aware. The universe is not indifferent, it is generative. We are the outcome of processes both violent and precise, chaotic and ordered. The revelation embeds a narrative of resilience, complexity, and interconnection at the heart of our understanding. Scientific inquiry itself has changed. The revelation encourages collaboration across disciplines. Astrophysicists, chemists, geologists, biologists, and engineers all contribute to unraveling our cosmic origins. Experiments now integrate astronomical observation, particle physics, and computational modeling, reflecting the complexity of the phenomena under study. Each new discovery builds upon the last, a chain reaction of knowledge echoing the fusion reactions that created the very elements we study. The consequences are ultimately temporal, emotional, scientific, and cultural, converging in the realization that humanity is both observer and participant. The atoms in our bodies, forged in the crucibles of dying stars, remind us that time is not merely a human measure. It is a continuum stretching from the birth of the universe to our fleeting consciousness. Understanding our cosmic origins transforms how we live, think, and imagine. In essence, revelation is not merely knowledge, it is transformation. The discovery that stars built us reshapes science, fuels technology, inspires philosophy, and deepens emotional and cultural understanding. It touches every aspect of human existence, from the instruments we build to the way we perceive our place in the cosmos. And as we move forward from this chapter, we see that revelation is not the end. It is a threshold leading directly to consequence and eventually to reflection. For now, the universe has spoken, and humanity listens, not just with intellect, but with wonder, gratitude, and an unshakable sense of connection. Must be approached with respect for the rarity and interconnectedness of the resources provided by the cosmos. Reflection is, therefore, not only philosophical but practical. It demands stewardship, foresight, and reverence for the material foundation of life. Culturally, reflection shapes imagination and creativity. Literature, art, music, and film increasingly draw upon the idea that we are born from the stars. Cosmic perspective influences storytelling, symbolism, and metaphor. Ancient myths spoke of gods crafting humans. Modern science tells a parallel story. The universe itself crafted us through elemental processes over billions of years. Reflection allows humanity to integrate this knowledge into meaning, identity, and inspiration, bridging the gap between science and human experience. Reflection also deepens the sense of interconnectedness. Every element in our bodies was once scattered across the galaxy. Every star, planet, and living being shares the same atomic heritage. This awareness dissolves boundaries between humans, species, and planets, revealing a profound unity. Reflection teaches that individual existence is inseparable from the cosmic whole. Life, matter, and consciousness are threads woven from the same universal fabric. Ultimately, reflection brings us full circle to curiosity. The story of our elemental origin is both complete and open-ended. Science has traced the journey from Big Bang to human thought, but mysteries remain. The nature of dark matter, the processes in neutron-star collisions, the conditions for life elsewhere in the cosmos. Reflection is the recognition that knowing the universe is not a destination, but an ongoing journey. Each discovery is a doorway to deeper questions, a spark for imagination, and a call to continue exploring. In reflecting, we also recognize the poetic resonance of our origins. Human language struggles to capture the grandeur of stellar nucleosynthesis, the delicate choreography of atoms, and the chain of events leading to consciousness. Yet reflection bridges the gap between knowledge and emotion, allowing us to experience both the precision of science and the wonder of existence simultaneously. It is a state of mind where the universe speaks, and we listen with intellect, imagination, and soul. Finally, reflection celebrates continuity. The atoms that once existed in stars, that traveled across galaxies, that fell to Earth in dust and meteorites, now live in us, observe through us, and perhaps will continue to travel through the universe long after we are gone. In contemplating this, we understand that existence is cyclical, interconnected, and meaningful beyond human perception. Reflection transforms scientific knowledge into a meditation on life, matter, and the cosmos. A quiet, profound acknowledgement that the universe has built us, nurtures us, and allows us to witness its grandeur. As this chapter closes, reflection leaves us with clarity and awe. We are the product of cosmic patience, stellar creativity, and elemental evolution. We are children of exploding stars, made conscious to understand and marvel at the universe. We are participants in an eternal story, bridging the past of billions of years with the present of thought, observation, and wonder. And in this reflection, humanity finds not only identity, but purpose, a recognition that understanding our origins is inseparable from reverence, curiosity, and connection. From the smallest proton to the largest galaxy, from stardust to sentience, the universe has built us, and through reflection, we understand not only what we are, but why it matters that we exist.